Good morning, everyone. Happy Friday. I hope everyone's had a good week. But you should be happy. I mean, it's the end of the week, Good Friday, payday, weekend. So I hope everyone's doing well. And today, what we're going to be going through is advanced steel, using it to generate a steel portal frame. So my name is Shoaib Yunus. I'm the BIM technical specialist in mining and infrastructure for Baker Baines. And today, I'm going to show you how easy it is to actually generate something like a warehouse or something with a structural frame. Very simple, very straightforward. So I hope you all enjoy. And yeah, let's get to it. Okay, so in terms of our agenda for today, we're going to be looking at what advanced steel actually is. For those that haven't heard of it or are new to the platform, I'm just going to take you through a quick rundown on what it is and what you can do with it. I've just created a slide in terms of the functionality overview, just some of the key features that actually stand out. Then we're going to deep dive into the actual software and generate the portal like you're seeing in the image on the right. It's from the same model that I have just created for this webinar. And then, of course, we're going to just conclude. So let's get into it. All right, so Autodesk Advanced Steel, what is it exactly? Okay, so generally, people know Autodesk as the AutoCAD people, which is so incorrect because now we have a host or we have a range of access to a number of tools that can actually help us to do a lot of design stuff much more easier, quicker, and of course, way cooler than actual conventional 2D. So what is Autodesk Advanced Steel? First of all, it's a steel modeling software. And we use it because it has a library of intelligent parametric structural elements. So if you haven't used it, there's a lot of libraries that have been pre-built into it that makes it so much better. And of course, we have also the South African steel sections that are built in there. And what I've done is I have actually used those sections in the model. So yay, local is lekker, right? So we're going to be using our own stuff in the model, which is quite cool. And of course, what you can model on the software, of course, your beams, your columns. The cool thing is the connections, because we've got something called a connection vault, which you will be seeing shortly, that helps making connections so much more easier. And then, of course, you can do plates, staircases, ladders, cage ladders, and of course, railings. So if you've been dealing with a lot of steel structures, I mean, these are the fundamentals or the skeleton, if I could put it, of any steel holistic structure. So all of that is covered in the software, which is amazing. And of course, if you're looking at miscellaneous or other model elements, we can also do concrete footings, which a lot of people don't know. I'm not sure why, but I've also included in the model that we're going to be looking at today. And then, of course, you can also add claddings, gratings, and other miscellaneous elements. So you can really do the complete structure. Today, I'm just looking at the steel elements of it. So we're not going to be doing cladding and gratings. I'm going to kind of give you a little homework to kind of figure that one out, but it's super, super easy once you're going to see the interface. Also, the cool thing here is the design to fabrication functionality. What I mean by that is if you do the steel connections and stuff like that in the software, you can automate the drawings, generate it, and you can actually output that to the steel cutting machines because you've got a .nc export as well as a DXF export. So it can be read by the machine and cut accordingly. So really, really end-to-end functionality. And of course, interoperability is the key factor here. We currently use it a lot with Revit. So if you're doing your Revit structure, you can actually, once you've got the structure locked down, import that into Advanced Steel and then do the detailing and get the shop drawings out from there. Also, integration with various other segments. So mining, civil infrastructure, plant, process plant. Steel is the primary component there, and you can actually integrate it with a lot of different workflows. So Plant 3D also has an AutoCAD base, which is quite nice. And of course, if you want to do your structural analysis on robots, you can actually do that using your Revit model, importing it in, doing your load combinations and getting it out as soon as possible. So You can use robot structures. I've met a lot of my structural colleagues, and it's actually working in our South African market. So go have a look at it. There's a lot of forums out as well. If you want some direction on it, my details will be at the end of the webinar, and we can take it from there. So in terms of our webinars, we call it Webinar Fridays here at Baker Baines, where we host a variety of webinars on different Fridays in different segments. So just to give you a quick rundown, we cater for architecture, engineering, and construction. Myself, I'm in civil infrastructure and mining, which like encompasses or links into all of the disciplines. We've got architecture, we've got process plant, we've got mechanical, we've got manufacturing. So we literally got all of these segments on lockdown, which is really, really cool. So again, at the end of the webinar, you'll get all our details. Please subscribe, follow, add us. I mean, it's free learning, it's cool, it's informal, and it's straight to the point. Okay, so that's just a bit of an intro. In terms of the advanced steel capabilities, right? So these are some of the things that actually stand out to me. Of course, modeling columns and beams, that's the foundation on any structure. The key thing here is the connections. It always gets detailed or it gets tricky when you're doing the connections. And like I said, with the connection vault, that makes it so much more simpler. And the great thing is it's visual, so you can actually see what you're doing. And if you make a mess up, you can actually undo it or just delete it and give it another shot. So very, very visual in that part of things. Staircases and stuff, probably I'll cover in future webinars. Concrete footings, you're going to see that today. Bill of materials is fantastic because you can actually do what we call a saw cut list, and it actually gives you a graphic of what you're cutting. It gives you the length, and you can actually export it to Excel and customize it. So it's really cool. General arrangement drawings, I mean, that goes hand in hand with the bill of materials or BOMs, right? NC data, that goes to the machines, steel shop drawings, your normal drawings as usual. And of course, you can do folded plates and sheet metal design as well. So really, really cool. And of course, the one that we've been looking at today is the one in the red block, portal frame design, which is going to be covered today. So in terms of the typical BIM structural workflow, if you don't know where advanced steel kind of fits in, there are a variety of workflows that actually it fits in different phases, but this is the most common one used, right? So if we're looking at the construction part of it or the modeling part of it, we're going to do that in Revit and Advanced Steel. So you'll do the main structure in Revit. And then of course, when it gets to the finer details, you can actually jump to Advanced Steel, right? So once you get it analyzed in robot, you can actually go to the detailing phase, which can be done. If you're doing rebar, you can do it in Revit structures, which is amazing with automated sections and 3D views. And then of course, the detailing of the finer elements, as you can see in the graphic. And of course, you can also jump directly from Revit to the Advanced Steel kind of things, depending if you not want to do the analysis part of it. And then of course, once you detail it, you can generate your shop drawings and so forth. And it literally looks like this, okay? You can customize the colors, of course, but if you like me and you want to use something just out of the box, it looks pretty decent. So please give it a shot. Okay, now to the fun part. Done with the intro, let's just jump into it. So what I've done is I've created it in steps. So if you have to go back to this webinar and follow it, you will be able to actually generate your own structure. So I hope you appreciate that, and let's get into it. So the first part we're going to look at is, of course, creating structural grid lines. Okay, that's the foundation of any structure, and let's look how we actually do this. So if I'm jumping in here into Advanced Steel, you can see on the Home tab, there's the structural grid there. And what I'm doing is I've actually used the 00 origin point, created my endpoint, and it's as simple as that. I mean, you can go back here and edit the measurements if you'd like. You can look at the groups, the axis indexes. You can see I've currently got 4. I'm going to use 4 for this one, right? And of course, you can go and edit each one individually. So here I wanted actually 3. Inputted 3, and you can see it updated instantaneously, and it also worked out the distance automatically. In terms of the layout, you can add edging, which is quite cool. We normally have that on our structural layout, and you can see the edging has been around the numbers. And then of course, we're going to do the second one. I'm going to make these capital letters. So typical, very simple, and done. Okay, if you want to move out those edgings, which we normally do, you can use a set distance, type it. If you want it like 1 meter to the left, 1 meter to the right, you can do that. I'm just dragging it out here just to show you how easy it is. And I mean, it's under a minute. In fact, maybe less than 30 seconds, and we actually have done the grid lines, which is fantastic, right? So I'm not doing anything out of the box. This is all comes in with the software. So we've set up our grid lines. The next one we're going to look at is the portal frame structure. So we're going to start actually generating it. So we've got our grid for the positioning part. The next thing is to actually input the columns, the beams, and of course, the rest of the structure. So let's have a look at that. Okay, so we're going to go to the extended modeling tab here, and you can see the icon on the left that looks like a frame. I'm going to select the start and the end point, and I'm going to enter a height here to the apex. So let's say maybe 10,000 millimeters, right? So 10 meters. And you can see the structure has already been generated. Okay. Now let's go and customize this. If you want to go and do this, the interface looks like this all the time. It shows you exactly which number affects what, and I've just changed the slope of the actual apex, if I could put it that way. And now we're going to go and look at the South African section. So there we are, SA. I'm using the IPE sections, and let's use maybe a 200. And then from there, I'm also going to customize the columns. So everything here, I'm going to use the SA sections. So again, local is lacquer. Our stuff is in here. And as you can see, it has been generated just like that. Now, how long would this take you in conventional AutoCAD to actually do this? It's kind of painful, right? If using AutoCAD 3D, it can be done, but come on, you gotta draw a polyline, extrude, enter your lengths and snaps, and it just gets a bit messy. And as you can see, it's a familiar AutoCAD interface, so you wouldn't really get lost. Okay, so we've got the initial structure. So again, the way I've applied it here is there are different ways or quicker ways that you could do it. You will deduce that as you see my presentation, but I've just done it so I can show you different functionalities of the software. All right, so creating footings and base plates now. This is where we're gonna attach a connection to an actual concrete footing. Let's have a look. Right, so what I've done is I've gone to the Objects tab, and I'm gonna place a footing at the center, and bam, literally like that. I'm just gonna adjust the dimensions, maybe make it 600, and the width, let's maybe drop it, also actually keep it square, and the depth itself is 300. You can adjust the positioning if you'd like, because as you can see, right, but we normally use center. And of course, you can see it's defined as a concrete foundation, which is quite cool. So the footing's done. Now, the next thing what we're going to be looking at is the connection vault. So here we are. This is how it kind of looks, okay? And what I'm going to do is going to use the first one, go to the base plate, going to select the column, and then because I've got a concrete object, I'm going to attach it to it. So it's going to intelligently link to it. And once I do select it, as you can see on the right-hand side, let's move this a bit. Yeah, that's your bolt, right? And your plate. So let's go and customize the shape of it actually. So the thickness, let's maybe make it 20, okay? And you can see it updated automatically. I'm gonna use it from the center as a reference. And then of course, I'm gonna keep it a square plate. So all the projections are equal and it's ticked. We use 200 and you can see it has updated automatically. So can you see how visual it is? Your inputs, you can actually see if you're inserting anything incorrectly. And I'm gonna create a convex. So the corners are kind of rounded or filleted. And I know we use a lot of Hilti on our projects. Hilti is built into here as well. So we used maybe a 20 millimeter, sorry. And you can see the bolt has been adjusted. Okay, and then that's the anchor grade because it's attached to the actual catalog. The anchor length, I've just made it longer. Let's have a look at it because we're in conceptual view. But if I go to 2D, can you see the anchor lengths going through there? It's anchored at quite a good depth. Okay, you can have hooks and stuff depending on the detail that you use. So we've done that. and you can see it's not going through the slab. So I've just showed you the bottom there. And what we're going to do now is we're going to just adjust the actual bolts, because I don't want the positions on there. I want it actually at the corners. So let's get back in here. Let's go to the actual anchor. You can attach washer plates and stuff like that. But what we're doing is we're just going to focus on the bolts. So I'm going to offset them, right? So that looks quite cool. That's a good distance that I want. Again, you'll know already in terms of your design what distances you're using, right? And now I'm going to offset it again. And now we've got 4 bolts. Okay, so don't forget the flange option. If you see it offsetting in a straight line, please use the flange option. And as you can see, it looks nice. It's what I want. And that is literally the base plate done with the concrete footing. Can you see how quick this is, right? You can see I've done this myself, all right? So you can't really judge me. There's my name there, okay? I just wanted to do it because it's so simple and so much easier to do. Okay, so we've created the footing. What we're gonna do now is the haunch connections. So let's get into that. So we've got a footing. So what I'm gonna do is I'm gonna copy this to that end there. Okay, so what I can do is I want it to come with the connection. And that's a cool thing with Advanced Steel. It's got intelligence attached to it. So I'm going to use the function there to copy the connection, right? And I'm going to place it there, right? So you can see that the connection has been generated on that side. If I use the advanced copy, which you're going to see later, I could actually offset this. So let's go and select it. So you should know the distance of your grid line. I'm going to select that footing. And of course, I'm going to offset it. Click OK. And here we are. So everything sits in correctly. And this is mostly the case when you're doing a portal steel frame, where it's more or less symmetrical and the details for the footings are more or less the same. Okay. So let's go back to the connection valve. And now what we're going to do is we're going to do the connection from the column to the side there, right? So we're going to use that. We're going to bolt it, and here we are. Okay, so we've done the side haunch connection. Again, you can customize it if you'd like, but in this instance, I'm very happy with it. It sits in correctly. It looks very neat. Okay, you can customize it using the interface that you've seen before, right? And let's do that again in case you didn't catch it. So I've selected the column, I selected the beam on top, and you can see it has been generated. Again, it's very visual. So if you're looking at it and you don't know what dimension you're dealing with, please have a look at the infographic that comes attached. And now the last part is to do the apex. Okay, so we're going to go there to the apex beam end, right? We're going to say apex haunch. We're going to select our 2 intersecting elements, structural steel. Okay, you can see I'm going to select the first one. I've just got my cycles on, so that'll pop up. Yours shouldn't if you don't, right? And here we are, done and dusted. Okay, so as you can see here, the bolts look really cool. I'm happy with it. Again, if you want to go and customize it, there's all the info that you can. Just for the interest of time, I've used it because it's set in correctly. And as you can see, we've got 1 connected element already done and dusted. Okay, so again, I hope you're seeing how much time we're saving here. All right, so we've got the, I would say the template, if I could call it, for the rest of the structure. And what we're going to do now is we're going to actually go to create beams with plate connections. So we're going to dive into the more of the connections part. So let's have a look at it. Okay, so what we're going to do is we're just going to confirm that distance. So you can see the offset distance is 6,000 or 6 meters, right? So that's what's my X coordinate. Remember, pay close attention to your UCS because that's going to guide you, okay? So what I'm doing is I'm using the advanced copy function, and I'm selecting the elements that will actually, I want it to attach intelligently to the rest of the grid line. Okay, so I've selected all the stuff that I need. Okay, so as you can see, I've got include additional connections checked. So it will take in the connections. And if you want to see if it's looked correctly, we're going to click preview, and you can see that's exactly what I want. If you entered the wrong distance, you can go and modify it. So I'm happy with it. I'm going to click OK, and I've got my 4 elements. See how quick that is, right? Again, these are all the SA sections that have been used in the software. So really, really cool. Now let's go and do some beams, right? So they normally call them tie beams, right? So I'm using the node snap here, so it automatically picks up the node center of an element, as you can see there, right? Again, your basic AutoCAD comes in handy here because that's where your snaps are. Again, you can see it's the SA section, the I section that I'm using. And what I'm going to do is, you can see that position is not correct. That's not what you would have in practice or in industry. And we're going to go adjust the position of it. Okay, so I'm going to drop that around the Z axis or the elevation, let's say 150. And you can see it instantaneously updates that, right? And it will update it on the other end as well. And let's go to the connection vault. What we're going to do is we're going to assign a single side end plane. And as quick as that, we've got the plate, but you can see that the positioning is not correct. Also, the bolts I think are too close. So let's go and edit that a bit. Okay, so I'm just going to toggle off that toolbar, right? You can dock those, or better use 2 screens, right? So I've just used 1 screen here, right? So these are the different type of positionings. If you set it to total, that block below it for the width becomes available to edit. So use total. If you see 120, you see it updated, right? But what I normally do is I go to the vertical bolts, I go to middle, right? And then you can see it jumps to a good position. And then from there, I can adjust the length or the height, whatever you want to call it. Let's say 150, and you can see it adjusted accordingly. So maybe I need to just a little bit more. Yeah, 180 looks about correct. Again, you'll have these dimensions when you're doing a design, so you don't have to guess it, right? And then just the bolt positioning, I don't want it too close to the member because of constructability issues, right? So let's say I'm happy with that. And you can see it looks pretty slick, pretty neat, right? Very visual again. So I've done the single side plate. Now let's go to the actual, let's maybe just add another one over here. So I've used the center point snap. Again, it'll normally be closer to the apex, but just for time, I've just used the center snap for illustration purposes. So again, we've got the positioning problem here. And you can see the angle of the, if I could say, the roof is not matching up with the actual section. So what we can do is, first of all, we're going to drop it to a degree that we will happy with. So you can actually see, because remember your IRB or your roof sheeting is going to go on the top. So you need a tolerance for that as well. So let's say maybe 50. Let's have a look. That looks okay in this model. So we've got the 50. And now you can see the angle still not matching up. So you can weld it or bolt it on straight if you'd like, but I just wanted to show you that you can actually align it to the roof. So it was 15, right? So let's type in 15. And as you can see, it matches the same slope. So very, very intelligent, very easy. You don't have to move stuff with the snaps. You can do it that way, but it's just difficult. Work smarter, not harder. Okay, right. So as you can see, we've got the angle correctly. Now I'm gonna attach another single plate. So if you didn't catch the first one, let's go through this again. You can see that there's a box or a gray box that's along or around the connection. Those are called connection boxes. And if you double click on them or right click and say advanced joint properties, you can edit it. So again, let's go and use the plate or edit the actual plate dimensions. Let's go to vertical. Like I said, we can do it. We can use different options if you'd like. Let's use maybe middle, right? So middle is the most convenient one. You can see it aligns really good. The angle has been maintained. And then after that, we're going to do the plate height. So again, just very quickly, let's just adjust that. I think 140 should be good for that one. The cool thing is when you insert the plate, it takes the angle that you've already selected. The bolts look fine, and I'm going to leave that as it is. So we've got the side connection, we've got that. And what we're going to do is we're going to not generate the other ones, but use advanced copy. So I'm going to select the elements that I want, right? You can see it selected 10 objects. And what I'm going to do is use the advanced copy mirror, right? I'm going to select my mirror points. So let's go to the apex. Let's select that center there. So you can see the AutoCAD snaps do come in handy here, right? Select that, click preview. If I zoom out, you can see it's correct. The connections come through with it. Like I said, very, very intelligent. Click OK, and here we are. We've got the first segment, if I could call it, done, right? Simple, easy, no complications. What you see, what you input is what you see, which I really like. Okay, so we've done the first segment, right? Now what we're going to do is, let's say we're not going to have single plates on all of them, because some of them you're going to need a double-sided plate. But what I'm going to do is I'm just going to select the members because they're selected or positioned in the correct place, and I'm going to offset them or copy them along my grid line. So my grid lines are spaced at 6 meters. I'm going to want 3. If I click OK, you see I didn't use the preview function and I've mistakenly added an extra one. So please use the preview, but you can go in, select the elements and delete it like I've done. So preview becomes very, very handy. Okay, so as you can see now, we've offsetted those beams. And what we're going to do is, I'm going to show you how we can actually copy connections here. Okay, so we're not generating them from scratch, but rather we're generating them from an existing template. So here we are, I assigned the connection on that side with the flat plate. And now what I'm going to do is I'm going to assign the flat plate detail on this side, right? So the single plate is in, right? So the corners are done, okay? And of course, you're going to need to do that for these elements here as well. So let's use that again. So we're going to use the create by template, select the joint that we like or an element from it. It could be a bolt, could be the plate. It'll identify it as part of that joint property. And then we're going to go and select the main beam and the secondary beam. And here we are, place that one in, do the same for here, right? Done. Okay, so the edges are done, the side connections are done, the single plates are done. The thing that's left now is the double-sided connections for the other ones, right? Okay, so because you've got 2 beams intersecting at a point, you're going to need a double-sided plate. So let's go back in there, right? Just move this to the left, and we're going to use, you see you've got single-sided and you've got double-sided, right? And of course you've got double-sided end plate. So they're slightly different, but let's use the one that's for double-sided. So our elements are going to be connected to that. That's the main object. And then the secondary beam is going to be the 2 beams that are connecting at that point. So once we do select them, right, here we are, we come back to the familiar interface. You can see same story here. The positioning needs to be adjusted, right? And let's go and adjust that. So you see the process that's built into it. It's quite uniform. And if you use the software more common or more often, you will get used to how the interface interacts. So let's go and just toggle at the interface. I'm going to change that to 12 in this case. And we can use the total. So the grayed out area becomes available. And this is where we can adjust the width. So we're doing, let's say 120. All right, and then the distances, you can offset the center distance if it's off. Here it looks fine. And then you can see here there's no middle, right? For some reason, because it's a double plate. So we're going to use, let's choose one, right? Let's say top, okay. Right, so what's the problem here? Why is it not snapping to the top? Very simple, you can see the layout distance got an offset of -30. Let's go and change that. All right, so if you make that 0, it snaps to the top. So don't get freaked out if you don't see that. It's just the input parameters that you need to pay attention to, right? So I'm more or less happy with that. And the intermediate distances, I'm changed that to 120. The bolts look kind of fine. The layout distance, I wanted 20 off from the front. And as you can see, we've got that. Of course, the bolts can be spaced a little bit more, but I'm happy for that in terms of this demonstration. So here we are, we've got a double-sided connection. You can see the connections evident on both sides of the actual column. Okay, the joint boxes are attached, so there is intelligence. And of course, we need to actually assign these to the actual the other elements. So let's give that another shot. So let's just do a recap again. We're going to select the same beam. We're going to select the secondary beams. And here we are. Let's have a recap. So I've done this because I know I go through it very, very fast, but you can actually grasp the concept. And if you're a designer, that's the thing that you actually want to grasp. If you understand the methodology applied to anything, grasping it or modeling it becomes much easier. So I focus on understanding rather than just click, click. Okay, so let's go and do this again. You can see the same offset of -30 is there. Let's use it from the top. Let's change that to 20 because we know the previous plate, how we liked it. And of course, you're going to do a plate height of, let's say, 150. Again, that looks okay. And then from there, we've got our two main connections. Okay, so if you want, while doing this, you could actually mirror the other ones. So if we didn't copy all of the elements initially, you could have actually mirrored it with the connections and it would have came on the other side. But like I said, for functionality overview, I wanted to show you that if you don't do it that way, you can actually go and copy the connections to the actual locations that you would like. Okay, so we're going to copy that connection. Okay, and what we're doing is we're just defining the input parameters, as you can see. Okay, because what we're going to do is we're going to need to actually copy to those type of members. So let's go and select the members that will be affected or need the double-ended or double-sided plate to be connected. So it will be those. Okay, and of course it's going to be connected to that, right? So people normally get confused at this stage, so I've done it here. So I've identified what we want. So we want to use that connection. We were going to assign it to the other elements that need that same detail. Okay, and it's going to be connected to those elements. So we can use the multiple copy, create by template multiple. We're going to select the joint that we want to be defined at those points, and it's going to be attached to those steel trusses, if I could call it that, right? So I'm just selecting them, right? So those are the ones in question. These are just the elements that are contributing towards it. Okay, so the ones that we have created and copied, offset it, I think it was at 6,000 or 6 meters. Okay, so let's just go and select them. So those are the ones that need to be affected. Hit enter and you can see the joints have been automated. Now tell me how much of time, how much of time does that save, right? It's crazy. Okay, so the functionality is built into streamline. So if you're a structural engineer, civil engineer like myself, you can actually do this, use it to your advantage. Okay, so we have literally done the entire structure. If you look at it, the connections are done, the footing's done, the haunch connections are done, the double-sided, single-sided plates are done. The grid lines, of course, were the first thing that we've done, and that's your structure. So I've just added in a bonus part of it. Adding bracing and gusset plates. Okay, this normally comes stock standard with a structure. I've just done one that's set as a diagonal, so you can more or less grasp the concept of doing it. And you can either do the normal X brace or you can do the diagonal one. I see the diagonal one is normally the most common one that we do use, but the methodology applied to any of them is the same. So let's have a look at it, right? So I'm going to I'm going to use a C section, and I want the column to, or the bracing to attach to the midpoints here, which is the normal case in most cases, right? All right, so I've put in my first member, okay, and I'm just going to hit enter. So again, you can see it's the SA sections or SA channels that we're using, and I'm going to enter another one here. Okay, so snaps are very important. Make sure that you have the pertinent snaps on, otherwise it'll go crazy. You know AutoCAD, right? And now we've got the two sections or the two elements that need to actually be created. So the first connection we need is to the column itself. and we're going to go to the actual general bracings tab in the Advanced Steel tool palette, and we're going to use gusset plate at one diagonal. So we're first going to define the column that it needs to be attached to, which is that one. We're going to design or designate that, and boom, right? Again, the familiar interface. You can see the joint box has been done there. And I'm just going to show you something with the gussets, right? So you can assign a plate thickness and stuff. You can play with it in terms of the layout. So if you don't want it chamfered, right? Alternatively, if you want it parallel, it'll run along the line of action of the beam. And what I'm going to do is I'm just going to leave it like that. And what I want is the bolts. I want it in the center. So you're going to change gauge line to actual center line, and boom, done. Okay, of course you can go adjust the bolt diameter and stuff like that, as you've seen already. Okay, and then we've got to take care of the actual top. You'll do the connection on the other end, but just for time, I wanted to show you. Now we're going to do it at the central point of the intersection. So it's going to be attached to that beam, and we're going to use those channels, define them, and boom, again. So you can see there's a lot of intelligence. It's crazy. People probably, when I show this to them as a demonstration or do a design in consulting, they go have that ridiculous face on their look on their face, getting a bit tongue twisted. But as you can see, it's quite quick, quite easy. You can customize it, and the interface is super, super easy. And that brings me to the end of our quick blitz portal structure. And you can see it was done in under, if you had to take the videos into account, or if you had to take the demonstration into account, it took me less than half an hour, and we've like 40 minutes into this webinar. So just to conclude, right? So it's from the same structure that we did now. You can use Advanced Steel actually to easily model steel elements, and you saw how easy it was. Again, you can go and use our South African steel sections, right? If you want to use UK and stuff, it's all in there. Of course, the intelligence of linking the base plates and other connections to other objects, like for example, the base plates and concrete footings, simple, straightforward. The haunch connections are so systematic because you can do the side haunches as well as the apex very, very smartly. And of course, the advanced copy functionality in the Advanced Steel tool palette is fantastic, because once you've got the initial frame that we did first and you just more or less recopy it and stuff like that, you can actually do it much more quicker, faster, easier, and get to your objective of generating shop drawings and stuff like that much more quicker. And of course, the objective that I have as a designer is, because I love design, you need to enjoy what you're doing and understand it. And this is actually going to help you do it much, much more quicker. So if you have any questions, any stuff like that, you can always contact us via email, right? You can see in terms of our contacts, if you want to follow us at Baker Baines, we've basically on all the main social media platforms. So LinkedIn is the biggest one, and of course the latest one is our YouTube channel. So all of these webinars are attached to our Baker Baines YouTube channel. So if you just type in Baker Baines, click a follow, and you'll have access to all of this content right there. In terms of LinkedIn, I'm also very, very vocal, and I post a lot of cool stuff on there, free learning, anything cool I see on industry, I always put it in there. So you're welcome to follow me. Please do reach out. We can have a chat. If you see anything cool as well, please share it with me. I'm really into design a lot. So that's my handle there on LinkedIn. And of course, if you want to drop me here at Baker Baines, an email, so it's shuaib@bakerbaines.com. If you have any suggestions for future webinars, something that's giving you more or less of a hassle, connect with me on LinkedIn and email, and we could actually do a webinar on it in the future. So yeah, I hope you enjoyed the webinar. Thank you so much for attending. I hope you have an awesome, awesome Friday. And I hope you gauged how easy it is to actually model something that's normally viewed as complex in our industry. So thank you very much. Enjoy your Friday, and I will see you for the next webinar. Thank you.